In this video, we are going to discuss about some more reducing agents. And that first one is H2 plus lindlars catalyst. What is a lindlars catalyst? Palladium, barium sulfate plus sulfur or quinoline and xylene. Here sulfur or quinoline, they will act as catalytic poisons. To stop the reaction at a particular stage, we are going to use this sulfur or quinoline. Now this palladium, we know that this palladium is a very good storage for that hydrogen. So therefore we are using this lindlars catalyst. Lindlars catalyst means palladium, barium sulfate plus sulfur xylene. Now what is the role of this lindlars catalyst? This lindlars catalyst reduce that carbon-carbon double bond into carbon-carbon single bond. That the addition of hydrogens is taken place that syn addition. Syn addition or cis addition. That means both the hydrogens are adding on the same side. Next, it is also reduce carbon-carbon triple bond into carbon-carbon double bond. It is reduced triple bond into double bond only. That the addition of hydrogens is syn addition. Next, this lindlars catalyst is converting that acid chlorides to aldehydes. All these are called as and reduction reactions. See, now we are taking some examples. How to solve these questions? See, now the given compound is ethylene. Ethylene is reacting with and lindlars catalyst. Then what will happen? Addition of hydrogens. So therefore it is called as and reducing agent. Now here what will happen? It is reacting with 1 mole of H2. Now this pi bond, this is a sigma bond, this is a pi bond. The pi bond is broken, then the addition of hydrogens is added on the same side of this double bonded carbon. So therefore it will use that and syn product, or it is called as syn addition. This pi bond is broken, then addition of hydrogen. This hydrogens is added this side, this side. This is lindlars catalyst. Next one is given compound is alkene. Then it is reacting with hydrogen. Now see, now this hydrogen. Now this pi bond is broken. Addition of hydrogens are taken place on the same side of double bonded carbon. Then we are going to get that syn product. CH2, CH2H, CH3. Okay, next given compound is alkyne. Now whenever it is reacting with and lindlars catalyst by the addition of hydrogen, reduction. Now pi bond is broken. Now this is the hydrogen. Now this pi bond is broken, addition of hydrogens. By using this simple method we can solve that questions. Just you break the double bond, add the hydrogens on the same side. Syn addition. This is called as syn addition. Lindlars catalyst is converting alkynes to alkene only. Further it can't reduce. Okay, na? So therefore it is called as controlled hydrogenation. Alkynes are undergoing controlled hydrogenation. We will get that alkenes. Okay, na? This is by using this sulfur or quinoline, the reaction is going to stop at the alkenes. If we are not using sulfur or quinoline, this is furtherly undergoing a reduction. Will get alkanes. But by using the sulfur or quinoline, the reaction is going to stop at the alkanes. So therefore it is called as controlled hydrogenation of alkynes. So now the given compound is acid chloride. Now acid chloride is given. Now it is reacting with hydrogen. Whenever they given lindlars catalyst, add the hydrogens. Now whenever they given lindlars catalyst, now one hydrogen, one chlorine, they eliminating as HCl. Then what is the remaining? One more hydrogen is remaining. So therefore we are going to get that aldehyde. Whenever acid chlorides reacting with the lindlars catalyst, the acid chlorides are converting into aldehydes. The acid chloride part is converting into aldehydes. Next here benzyl chloride is given. Whenever it is reacting with and lindlars catalyst. Okay, and then what will be happen? This compound is converting into what? Acid chloride is converting into an aldehyde. Now we are going to get an benzaldehyde. This is the advantage of that what? And lindlars catalyst. It is a gives a syn addition of hydrogens on the same side, so therefore it is called as syn addition. It is controlled hydrogenation. Next, another reducing agent is H2 palladium carbon. Now every year in either JEE mains or NEET exam or CBSE board exam, minimum one question is asking based on that what reagent type questions. Okay, no? Now H2 palladium carbon. Now it is also one of the reduction reaction. What these groups are doing? Now these groups are converting NO2 group into NH2 group. Nitro compounds are converting into amine compounds. Cyanides are converting into amines. Azide is converting into amines. Okay, no? This group is converting only these compounds. No other group is reduced. No other group is reduced. Only this H2 palladium will do this one. Okay. Next one is metal plus acids. Now these are also called as what? And reducing agents. Metal plus acid. Zinc plus HCl. They are liberating hydrogen. Zinc plus acid liberating hydrogen. Zinc plus acid liberating hydrogen. Metals are reacting with acids liberating hydrogen. Metals are reacting with acids liberating hydrogen. All these are what? Providing that what? Hydrogens. All these are providing hydrogen. So therefore the compounds are undergoing that what? Reduction. And now see, now these acid groups, metal acid groups are converting carbonyl compound into alcohol. Carbonyl compounds are converting into alcohols. Next, nitro compounds are converting into amines. Cyanides are converting into primary amines. Isocyanates are converting into secondary amines. Okay. Now these cannot reduce carbon-carbon double bond or carbon-carbon triple bond. These metal acids cannot reduce carbon-carbon double bond or carbon-carbon triple bond. Now solve this question. Now they given nitro compounds. Whenever they are reacting with H2 palladium carbon, then the nitro compounds are converting into what? Amines. Just you convert NO2 group into NH2 group. These are very, very useful for conversions reactions. Next here, cyanide is converting. See now this cyanide part is converting into what? An amine part. Okay. Now this cyanide part is converting into what? An amine. So that means CH3, CH2, CN is converting into CH2, NH2. Okay. Next, azide part is converting into amine. Same here also. This azide part is converting into what? Amine. Next, elimination of nitrogen. Elimination of nitrogen. Okay. Now metals plus acids. NO2 group is converting into NH2 group. That means removal of hydrogens and addition of removal of oxygens and addition of hydrogens. Metal plus acid. See now metal, what is happening here? See now first zinc, metal, it loses 2 electrons. Then it is converting into Zn plus 2 minus. Now HCl means what? HCl means it is nothing but what? H plus ions. HCl means is nothing but what? Cl minus H plus. Now H plus means it does not have any electrons, no? So therefore this electrons is gained by what? This hydrogen. So therefore this is converting into what? For suppose now when we are taking this, 2 H plus ions are converting into what? 2 hydrogens. 2 H plus ions are converting into, each H plus ion is gaining 1 electron, then they are converting into hydrogen atoms. Now these hydrogens are reacting with this. These hydrogens are reacting with this. Okay, now then this pi bond is broken. Here addition of hydrogen, here addition of hydrogen. This pi bond is broken. Here addition of hydrogen, here addition of hydrogen. That means we are taking 4 moles. Like this, we are going to get that what hydrogens whenever metals are reacting with acids. Metals are reacting with acids, they are always providing hydrogens. Okay. Now here finally what we are going to get CH3, CH2, now CH2, NH2. Okay. Next here double bond is given. These metal acids, they want to reduce the carbon-carbon double bond, so therefore it won't affect. Next here isocyanide is given. Isocyanide is given means it is reacting with what? 4 moles of hydrogen, then it is converting into CH3, CH double bond CH. Next to CH2, now this NC compound. Now nitrogen double bonded with what? Carbon, triple bonded with carbon, so therefore it is converting into secondary amine. Cyanide means it is converting into what? And secondary amine. Cyanide means it is converting into primary amine. Isocyanide, it is converting into secondary amine. This is primary amine. Okay, thank you.